Let's tackle another interview staple that you might see in problems related to calendar, scheduling, or data consolidation. Merge intervals. You are given a collection of intervals, where each interval has a start and end time. Your task is to merge any intervals that overlap and return a new list of clean, non-overlapping intervals. For example, 1-4 and 3-7 overlap and should be merged into a single interval, 1-7. The secret of this problem is to stop thinking about code and start thinking about your daily calendar. You have a messy list of meetings. What is the first thing you do to make sense of it? Step 1. You sort them by their start time. This instantly bringing order to the chaos. Step 2. You merge them. You go down your sorted schedule. If the next meeting starts before your current meeting's block ends, they overlap. You simply extend your current block to cover both by taking the latest end time. If it doesn't overlap, it's a new separate meeting block. That is the entire algorithm. Sort and merge. It's that simple. Now let's see it in the code. We sort the intervals based on their start times, the first element index 0. This allows us to make a simple greedy choose at each step. We ask two things: if our result is empty, or is the end of our last merge interval before the start of current interval. If either is true, there is no overlap. If there is one overlap, we simply add the current interval to our result list. There is one overlap, we don't add any interval. Instead, we just update the end of the last interval in our list. We set its new end time to be the maximum of its old end time and the current interval's end time. The performance of this algorithm is dominated by the initial sorting step. Sorting an interval takes O(n) log n time. After that, we have a single loop throughout the intervals, which is O(n). Therefore, the total time complexity is O(n) log n. For space, we are creating a new line to store the merge intervals. In the worst case, if no interval overlap, we will store all n intervals. The space required for the answer is O(n). Don't forget to like, subscribe, and give a comment. See you in the next one.